In topic 2, justifying line and angle relationships. And we're in the first lesson, lesson 1. If you haven't watched page 279's video, that is the setup for this lesson, and it reminds you or asks you to get some note cards and start putting the vocabulary words that we cover in each of the pages. Have something to write with. Have a straight edge, have a ruler, have some highlighters, even some colored pencils, things that you're going to need in order to be successful for following along with this lesson, with this video. Now, in this video, we're going to talk about, in page 280, how can we determine that vertical angles are always congruent? And it directly relates to the learning goals, where we start recognizing these postulates that are the rules or the definition statements, the building blocks of proof. So we'll start with one of the most important ones that shows up all the time, and that is vertical angles. And vertical angles has this special relationship that we need to be able to identify or recognize. Also, like I said, have some note cards ready to go because we're going to be using them. And if we come across a vocabulary word that's in our note cards, we should actually write down some definitions. And so I'll share with you in a screen recording what I wrote down. Let's first of all consider this setup here. So with my highlighter, with my color pencil or my regular writing tool, how can you prove, this is the big geometry word, that vertical angles are always congruent? Consider AB, which is a line, and line CD. And they intersect at point E. And we want to know, so if we're considering them, we're going to maybe answer question 1. I got a question for you. What angle has a measure that is equal to the measure of angle AEC? So I'm going to highlight that in. Plus the measure of angle CEB. If you put those two next to each other, notice that being next to each other, they actually end up forming what we call a linear pair. And so later on down the line, we'll talk about what the linear pair postulate is. Just look later on down the video, or down the paper and later in the video. But if you add those two together, what do you know about them? What would be the sum of the measure of angle AEC plus the measure of the angle CEB? They happen to form a straight line that makes them supplementary, and so therefore together they add to 180 degrees. How do you know that these pairs of angles are supplementary? I mean, what is the measure of a straight angle? A straight angle being the angle that you get from a line. It still has 3 points, but it makes a straight line, and it's 180 degrees. How do we know? I mean, those two angles form a linear pair. The angles, we're going to write some sentences here. The angles form a linear pair. All right. Is angle AEB a straight line? I mean, is it, right? Is this angle A to E to B, is it actually a straight line? I mean, we're going to trust that it is, I guess. We're going to make some assumptions, but that doesn't necessarily mean that it's always going to be that way. How do you know that the measure of angle AEC plus the measure of angle CEB equals the measure of angle AEB? Lots of letters. I get it. How do you know? Well, I mean, if those angles, right? So angle AEC and angle CEB share a common vertex. And that vertex is E. They also share a ray in common. And so the ray that they share in common actually is this ray, EC. And so for that reason, they have to be added together. And when you add them together, what you get is the angle AEC plus the measure of angle CEB. Like they add together. And make AEB. Okay, how do you know your reasoning to question 3 is true? I mean, If I remove this line, if I cover it up, did that really change angle AEB? No. Put it back in. Now we have two angles. Cover it up, one angle. But nothing really changed between what we get with the ray EC being there and it not being there. Okay? If I cover ray EC, the angle AEB does not change. And it's still there. These questions never seem to have an end. In fact, here's one. Why do you think the segment... Oh, I'm not there yet. I'm going to say the question for after this one. These questions seem to never end. That's why mathematicians have agreed upon postulates in Euclidean geometry. Euclid is a Greek librarian, really, but he was the first author for a geometry book that existed for thousands of years. And all geometry curriculums now are based upon, in large part, what he did. You previously made conjectures about the sum of the measures of angles and arcs. We did that in the last lesson, last topic. These conjectures are postulates. So a conjecture is a rule, and a postulate is a more specific rule. You learned about the following postulates in a previous topic, and they will come in handy as you begin to prove your conjectures. Please take some note cards, and let's start with the angle addition postulate. Write it down. Angle addition postulate, put it on a note card. In fact, on the back of that note card, write the definition, and so that's what's right here in the space. Let me get rid of my face and just put it right there. Take a screenshot. Make this be your angle addition note card. That's enough time for you to pause, go back and find it. Let's do the next one. Linear pair postulate. If two angles form a linear pair, then the angles are supplementary. Okay, so on the back of the linear pair postulate card, write the definition down and draw the diagram. Two angles that form a linear pair are supplementary. Let's do the last one. Again, the magic of YouTube. Segment addition postulate. If point B is on line AC, line segment AC, and is between the points AC, then AB plus BC equals AC, or the measure of AB plus the measure of BC equals the measure of segment AC. So there's your segment. We added them together. That is it for page 280. Thank you for watching this video. Thank you for doing some math. We're going to continue our journey on page 281. So I encourage you to flip over to the next page, click on the next link to the next video, and keep learning. Thank you so much. See you in the next video. Bye.